Here we go. So lesson 1. Some of this, I start out Physics 11 fairly similarly as well, but then we're going to get into more of a mathematical tangent. I always start out with asking, hey, what is physics? And I had a physics prof who said to me, physics is the science of measurement. His argument was, if you're measuring something, you're doing physics. I said, okay, that's pretty good. But it leads to the obvious question. Well, what do we measure? And here are the big 3. We measure time in units, seconds. We measure length in fundamental units, meters, spelt R-E in Canada, ER in the US. Not that they'll ever use meters. Stupid US. By the way, I think I told my Physics 11s last year that there was 2 countries, Liberia and the US, that still hadn't gone metric. Liberia went metric last year. So the US is the only country on the planet that still hasn't gone metric. And the other big one that we measure is mass. Units for mass should be grams, but they're not. And part of the reason is a gram is so ridiculously small, but it is a bit strange that the fundamental unit for mass does have a metric prefix. What's the unit for mass? Not grams. What do we measure mass in? Kilograms. Mathematically, it's always kind of bugged me because it's seconds, meters, kilogram. Okay, whatever. So these are part of the SI units, which is French. It stands for the Système International. The base quantities are, so we have length in meters, time in seconds, mass in kilograms. And then there's 4 other ones. These 4 are defined. All the other units that you'll learn this year are actually parts of these. So for example, you already learned that the unit for velocity is meters per second. It comes out of the first 2. You learned that the unit for acceleration is meters per second, or meters per second squared. So it comes out of the first 2. All the other units that you'll be learning, joules, volts, Teslas, all of these units come out of these 7. So who knows or who remembers what do we measure electric current in? Hertz is actually frequency and how you feel when your brother tackles you. Hertz, right? Yeah. Sorry? Watts? No. Watts is defined actually out of this next unit. No. Symbol, capital A, named after Ampere, a scientist who did a lot of work with electricity. Temperature, well, the unit is degrees, but then there's the temperature scale. The unit is really degrees Kelvin, and I always like this because my name is Kelvin, spelled that way. I always tell students it was great. A few years ago when Google first came online, if you Googled Kelvin, the first web page that came up was a fan site for Lord Kelvin, who is the mathematician for whom this is named, and it just said in huge letters, Kelvin is God. The first search for my name said I was God. Then Google redid their stupid algorithm. Actually, William Thomson was his real name, but Lord Kelvin was his title. It's kind of disappointing that this is named after him. He was a brilliant mathematician, but his understanding of electricity was so wrong. You can argue, and he was very influential and very powerful, you can argue he set back electricity by about 50 years because he believed it should be done a certain way, and he exercised all of his opinion. He believed that his understanding of electricity was wrong, and he really went after one of my heroes, Michael Faraday. But anyways, amount of a substance. You learned this in Chemistry 11 last year. It's also a small little animal. Yep, if you've seen one, you've seen them all, right? And then my favorite out of these 7 units is the last one. It has the best name. All of these the previous 6, when you tell me what they are, I can't immediately tell you how big one is. When you say second, I don't know that 1 second is, unless I've grown up and I've seen a wristwatch a whole bunch. If you tell me kilogram, I don't know how big a kilogram is. Who remembers the unit for light intensity? It's my favorite. Candles. And as soon as I say 1 candle, you all know how big 1 candle is. That's a great unit in my mind. How bright 1 candle is. So it's candles, symbol, Ca. Having said that, we won't use moles this year. You will in chemistry. We don't use candles in physics in high school at all. In fact, I never used them in first-year physics either. In addition to the base units, the SI uses a prefix system, kilo, giga, etc. On your formula sheet, there is a chart that has all of the prefixes that we'll be using this year. So no, you don't have to memorize them. There will be 2 that we will end up memorizing. We'll end up memorizing micro when we get to the electricity unit, because we're going to be doing all of our charges in microcoulombs, and we'll get tired of looking up that micro means 10 to the negative 6. And so I'll say to you, look, memorize it, because you're just going to get sick and tired of looking it up. And kilo, I'm kind of assuming most of you have. 1,000. I found this in the summer, an easy way to compare temperature units. So if you have 0 versus 100 degrees Celsius, 0 is really cold outside, 100 is really hot outside. 0 versus, or sorry, you know what? The Fahrenheit got chopped off. This is Fahrenheit up here. I've copied the graphic wrong. Fahrenheit, I think is how you spell it, but who the heck knows? The US would know. Maybe that H isn't there. Is it that? I think it's that. So Fahrenheit, 0 degrees is really cold. 100 degrees is really hot, but very survivable. Celsius, 0 degrees is fairly cold. 100 degrees, you're dead. We can survive up to about 60 degrees for like 10 minutes or so, but much past that, very quickly your body overheats. And then Kelvin, 0 degrees Kelvin, you're dead. 100 degrees Kelvin, you're still dead, because that's still well below 0. And I copied the graphic wrong, and I got to go find that thing. Yeah, okay. During this course, we'll often use models, often mathematical, to help us understand a particular set of phenomena. And I cannot emphasize this next part enough, Holly. Almost every single thing that I teach you this year is garbage, is wrong, is wrong. Often we'll ignore friction and air resistance, or we'll ignore dissipative forces, we'll ignore energy loss. But there'll be good approximations. But even the basic, by the way, there is no such thing as friction force. There is no such thing as the normal force. There's 4 fundamental forces in the universe. There's the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. And all the other forces are combinations of them. But you know what? It's much easier in the models that we're doing to pretend that there is a normal force, to pretend that there is a friction force. It makes the math and the understanding and the prediction much better. But it's wrong. And such is life. Heck, most of what you learn in chemistry is wrong. If you think electrons actually whirl around the nucleus, no, they don't. Anyways. Since our models will be mathematical, good math skills are very helpful. So here is a review of the basics. One of the things you're going to need to know how to do is how to solve a quadratic equation. Well, first of all, what is a quadratic equation? What makes a quadratic a quadratic? It's really easy to tell. It's got a squared, okay? And no bigger exponent. It's got a squared, it's a quadratic. How do you solve a quadratic? Well, in Math 11, one of the tricks you learn is how to factor. And I'm okay with that, except most of the stuff we have this year won't factor, because we're going to be dealing with real life data. By the way, the big quadratic, well, the big 2 quadratic equations this year are this one. Don't write this down. There's your squared, it's a quadratic. And then the VF squared equals VI squared plus 2A. Hopefully you heard me say squared a few times there. That's a quadratic as well, although that's a bit of a nicer quadratic usually. How do you solve one? Use the quadratic formula. First, though, before you use the quadratic formula, what do you have to do? Got to make it equal to 0. In other words, as is right now, I can't solve this. First thing I would do always is I would rewrite this and make this equal to 0. I would plus the 2 over. So I'll get 5t squared plus 7t plus 2 equals 0. This factors. Does anybody know how you can glance at one of these and tell that it factors? Because there is a trick. Okay? Boy, I got to teach some math. Anyways, tricks of the trade from somebody who's a math nerd. Rachel, what's the first number of that quadratic, the first coefficient? What's the last term, the constant term? Yep. What is 5 times 2 in your head? 10. Okay. Are there numbers that multiply to 10 and add to 7? Then it'll factor. And it might not factor with that 5 and that 2, but the fact that there are numbers that multiply to the front and back and add to the middle, it does tell you that if you want to, you shall be try factoring it. But I know most kids, when they see that their quadratic formula, they kind of fall in love with the plug and chug, hey, I've got a system approach. So although this will factor, we're going to use the quadratic formula. The fact that it does factor means that when I go to my quadratic formula, I should get nice answers. I shouldn't get long, irrational decimals going on forever. I should get either even numbers or like 9.6 ending. What is the quadratic formula? What is the quadratic formula? I'll give you a hint. X equals negative b plus or minus. She was a little off. She stuck an extra negative in there. X equals negative b plus or minus square root b squared minus 4ac over 2a. Can we say it faster than that? Anybody say it backwards? Really? I'm the only one? A2 overall. CA4 minus square B root square plus or minus plus B negative equals X. I love the quadratic formula. I love it, Josh, because it's the only one of its kind. It's as close to Shakespearean iambic pentameter as you'll ever find in math. The quadratic formula, we've known about it for about 900 years. And once it was found, a logical question followed among math people. Hey, if there's an equation that will handle any squared, is there an equation that will handle any cubed? Is there a cubic formula? Is there an equation that will handle any fourth luna? Is there a luna, right? In fact, the question, Emma, they wanted to find, is there a generic polynomial solving equation? And it was only around 1880 that it was proven that the quadratic is one of a kind. There is no cubic formula, there is no quartic formula, there is no quintic formula. But it drove a lot of different branches of mathematical discovery trying to find it. And it's a very complicated proof showing that it can't exist, but we know it's there. Now, excuse me, Ashley almost had the quadratic formula memorized. Here's the good news, Ashley. I think it's on your formula sheet. On the page that has 2 pages with lots of small printing, I think it's there somewhere. Is it not? On the page that has 2 pages and really small printing, the data portion. Yeah. I think on the right-hand side there's some trig. I think they even give you Pythagoras, which to me is embarrassing. They give you the quadratic formula, yes, and a few other things. Anyways, know what's there. You don't have to memorize it. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sam, you had me in Math 10 back in the day, right? I like to be organized and lazy. Okay? What do I mean by that? I could now rewrite what A and what B and what C is, but why rewrite it? I have the quadratic sitting there. You know what I tend to do? I go like this. Making sure if there's a negative in front, I include the negative in the box. So if you're someone who likes to like relist them, that's totally fine with me too. But to me, I could accomplish the same thing with less work. I'm going to be fussy because I'm a nerd, but I won't take marks off. This is wrong. That's technically right. I won't, if you put an X there, I'm not going to freak out. But since we're solving for t, Ashley, I can't leave it like that. That's like fingernails on the blackboard for me. Can't stand it. Okay. Now it's plug and chug. Complicated plug and chug, but plug and chug. However, who has a quadratic solver on their calculator? Those of you that have, you can quit now, go to your software, and if you write down the answers, I will assume that you did it by longhand. In other words, if you show me the formula and you show me what A, B, and C are somehow, I'm good. But for now, just to follow along with the rest of these poor peons, let's fill in stuff. Justice, what's B? So what's negative B? Plus or minus the square root of. I tend to do b squared in my head unless it's a decimal, but I'm pretty good at squaring stuff. So you can write 7 squared, but I tend to write 49. Minus 4 times 5 times 2 all over. And then I usually tend, Luna, to do the 2a in my head, because even if it's decimals, I can usually multiply by 2 in my head. So I'm going to put a 10 there. Mr. Dueck's tip number 2, because I see, Jake, so many calculator mistakes on this. I strongly recommend, before you do anything else, enter what's inside the square root on your calculator and get that as an answer. This is one of the only times when, to me, the work of showing one line of extra work far outweighs, the benefit far outweighs any extra work. In other words, what I do now, I don't go straight to my calculator and type in the whole thing. I go 49 minus 4 times 5 times 2 equals. And I say, oh, what's inside the square root is a 9. I say, this is really negative 7 plus or minus the square root of 9. Yes, I know it's a 3 all over 10. By doing the square root solo, I find that gets rid of about 90% of the typos. If you feel comfortable doing the whole thing in one schmear, go ahead, I'm fine with that, but for what it's worth. Because the square root of 9 works out evenly, now I might be tempted to go to my head. I might say, oh, it's negative 7 plus 3, which is negative 4 over 10. And it's negative 7 minus 3, which is negative 10 over 10. And then, unlike math, in physics, we prefer our answers as decimals, so I'd probably convert the negative 4 over 10 to the negative 0.4 on my calculator. Oh, they're both negative root. I guess they are. Quadratic solver humans, am I right? Now, who didn't have me last year? Get out your calculator, please. Here we go. B. You know what? I'm going to skip B. Let's go to C. By the way, B is a bit strange because one of your A's and B's and C's are 0, but that's fine. Let's do C. This is actually, I stole this one from physics. The negative 4.9 is actually half of 9.8. This is a variation of D equals VIT plus a half AT squared. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. What do I have to do before I start solving any quadratic equation? Got to make it equal to 0. Now, Ryan, I have a preference. The easiest way to make this be 0 would be to plus the 10 over, but I have learned from personal experience that I make more mistakes when the squared term is negative, and it drives me crazy. So I have the habit of always making that squared term positive. So, and I'm good at just moving stuff from side to side in my head of an equation anyways. So I'm going to choose to plus this to this side and minus this to this side. It's not wrong to do it either way. It's just, I've learned over the years, I try and eliminate dumb mistakes whenever I can ahead of time. So I'm going to actually go positive 4.9 t squared minus 12t minus 10 equals 0. Is that okay? You okay, Sam? Yeah? Okay. Let's write down the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, if you want to, if you feel comfortable by going now a equals blah, 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 b equals blah, 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 c, go ahead, knock yourself out. My tendency is to go, hey, that's a. I'll make sure the negative is in there. That's b. That's c. And now it's plug and chug. Complicated plug and chug, but plug and chug. 12 plus or minus the square root of negative 12 squared, 144. Minus 4 times 4.9 times negative 10 all over 2a. You know what? 4.9 times 2 is 9.8. Hey, that's the acceleration due to gravity. Maybe that's where Mr. Dueck stole that number from. Is that okay, Emma? Yeah. Oh, you got a solver. You're ready. You're waiting, aren't you? Sorry. It's like, why is she sitting? Oh, she's done. 12 plus or minus the square root of. By the way, a little comment on calculators. Can you all look up for a second? What's b in this question? Negative 12. So what's b squared in your head? Okay, if you go on a good calculator, negative 12 squared, it'll tell you negative 144 because it doesn't know you want it to square the negative. And I'm telling you to get a good calculator. That one, by the way, will square the negative, which is also why it's a POS, but that's okay. Get in the habit, if you're doing a negative, it goes inside brackets with the exponent outside brackets, and then you'll always get the right answer if you're not doing it in your head. So it's going to be 144 minus 4 times 4.9 times negative 10. And I get 340 all over 9.8. Ready, Ashley? So here's the first one. 12 plus the square root of 340 divided by 9.8. And I'm about to rub salt in your wounds, my angel. You know exactly, throw 3.1, and then I go second function, enter, and I just change the plus sign to a minus sign. I don't have to retype anything else. There's my plus or minus. So I get, those of you who have solvers, at 3.1 and 0.66? Negative, sorry. Negative 0.66. And then if this was a time question, Marissa, we'd toss out the negative. We'd say, time isn't negative. And we'd say 3.1 is the value we were looking for. Okay. I'm not going to do D. You're going to get some homework and you're going to practice solving some quadratics. So brushing the cobwebs off of our brains, I hope. Formula manipulation. I think this is a great skill. You do not have to do it. You can plug in numbers ahead of time and solve everything, but I really think if you get yourself comfortable with doing math with variables, you make less mistakes. So, I said, here's my equation. AB squared plus C equals D, and then solve it for A, which means get the A by itself. Okay. How would I get the A by itself? What else is on the same side as the A? A B squared. What's the B squared doing to the A mathematically? Adding, subtracting, multiplying, or dividing, Ryan? You're right, multiplying. When you're solving an equation, because you're going backwards to find the answer, you reverse BEDMAS. In other words, I'm going to deal with the multiplying last, not first. What else do you see on that side? What, and you said plus, so how would I move the C over? How would I move the B squared over? If you can do that in one step, if you can say A equals D take away c and divide all that by b squared. I say to you, knock yourself out and go ahead. I will not make you show that work. In fact, I gotta be honest, my preference is you learn to do it that way and not show the work. It's not often you hear someone teaching math or physics who says, don't show work, but I know where we're ending up, Emma, and I can save us lots of time if we can get good at this. In particular, equation B, where I notice I have one fraction equals one fraction, and it wants us to get the a by itself. Okay. What else is on the same side as the a? A squared. How would I get rid of a squared? And in BEDMAS, I do exponents like first, so I'll do that last when I'm rewriting this equation. What else is on the side of the a? Divided by BC. What's the opposite of dividing by BC? So you're saying multiply by BC, check, and then? So if I hear you correctly, and I think I do, you're saying A equals, there's going to be a B, a C, a D, over E, and then that whole sucker gets square rooted. Is that what you were saying? Well, hey, maybe that calculator won't hamper you after much after all. C. We did this one quite a bit last year. Good old D equals VIT plus a half AT squared. And it says solve for T if VI equals 0. Well, if something equals 0, what's VIT? What's VI times T? So I tend to go like that. I'll rewrite this so it's a bit cleaner, Holly. It looks like this. D equals AT squared. It's a half AT squared, but usually shall be if I have this one. Instead of writing a half in the front, I just put it over 2 because that looks much cleaner. We did this one a bunch last year. Kyle, my friend, how would I get the T by itself? Times by 2, check. What else? So you know what? I'll do that. Divide by A, square root, that equals T. Or T equals that. Handy shortcut I always point out, this is cross-multiplying with a vengeance. If I have one fraction equals one fraction, much like equation B, who remembers from last year I tried to show this? I can move stuff what? Do you remember? Stuff moves diagonally. Logan, that's going to be handy when we get to gravitation. Don't write this down, but when we get to gravitation, we're actually going to have an equation that looks like this. That puppy, which is one big fraction equals one big fraction. We're always going to notice that the little m cancels. We're going to say, woohoo! And then we're going to say, you know what? A t squared down there is the same as a t squared up there because stuff moves diagonally. That's the same equation. Oh, I jumped all of a sudden. Or we're going to say, you know what? An r up there, that's the same as an r cubed down there because stuff moves diagonally. It's the same equation. And if you get good at that, you've saved yourself like 10 minutes of rewriting, and it's handy. So stuff moves diagonally, but that trick only works when you have one fraction equals one fraction. Let's get tricky with it. No? Tough audience. Who's in Precalc 12 this year? Okay. Sometime around probably November in Precalc, you're going to be introduced to the wonderful world of radians. And you're going to set your calculator to radians. In physics, we're going to be using degrees. Radians are superior in every way, but in physics, we use degrees. So you're going to have to get into the habit of making sure that your calculator is in degrees. If you have a good graphing calculator, anytime it resets, by default, it will reset to radians, because that's what we use most of the time in math. So how do you know if you're in degrees? Usually, if it's a scientific calculator, there will be a D on the screen. If you have a graphing calculator, the quick and easy way, find the sine of 30. It should be 0.5. If it's not, you're not in degrees. That's one that I've memorized. Sine of 30 is a half. Okay, so you all made sure your calculator's in degrees. Good old SOHCAHTOA and the sine law and the cosine law. So I have solve. First thing I notice, Grant, this is a triangle, so I can use trig. Second thing I notice, what type of a triangle? I see a very specific angle, a right angle, which means I can use SOHCAHTOA and Pythagoras. Otherwise, I have to use the sine law and the cosine law. So that's kind of the mental checklist, and most of you probably are at the point where you do that so quickly you don't even realize you've made that mental checklist. But hey, it's a triangle, it's a right angle, SOHCAHTOA. So I'm going to start labeling sides. That 13.1, is it opposite, adjacent, or hypotenuse? What about that x, adjacent, or hypotenuse? Now, if there's one habit I'd like to break you of, I notice that there are some teachers who just teach kids to label all three sides automatically. Putting an A on the vertical side is A, a waste of time, and B, it just makes it more confusing. Because right now, what two letters are there? O and H. Which trig function is it? Sine. So, O and H. If you put the A there, you leave yourself open to the mistake that Ashley made. You might look at the wrong letter, and so you're doing extra work to make it less clear. And I think when I taught some of you in grade 10, I probably did the same rant on trig in grade 10. Don't label stuff if it's blank. Only label if you need it. So, Ashley, which trig function? Sine, not sin, sine. Sin is when you swear in my class. Sine is the trig function. What always goes next to the trig function? The angle. If you don't know the angle, that's where the variable goes, traditionally theta, because that's what we tend to use for angles, equals opposite over adjacent. 13.1 over x. Ding, 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 ding. Mr. Dueck. Yes, Carly. Mr. Dueck, isn't that technically, look up, 1 fraction equals 1 fraction? Why, yes it is, Carly. So, Mr. Dueck, doesn't stuff just move diagonally? Wouldn't the x move to the top on the left and the sine 58 move to the bottom on the right? Why, yes it would. You could, it turns out, use that clever diagonal shortcut for solving trig equations too, if one wished. I forgot to check if I'm in degrees. Good. $15.447. Okay. Let's talk about sig figs and answers. I'm going to be very pragmatic this year. Give me all of your answers to 2 or 3 sig figs. When you have better lab equipment, if you take post-secondary physics, where they have the tolerances on the equipment, and you know how many sig figs this piece of equipment goes to, and how many sig figs this piece of equipment goes to, and you're doing labs and you're measuring data, then sig figs become more important. But right now, I'm being pragmatic. So I'm going to go 15.4. Units, meters. So, SOHCAHTOA. You can also use trig to find an angle. So, is it a triangle? Yes. Is there a right angle? Check. Okay. Let's find theta. Ashley, the 12.6, opposite, adjacent, or hypotenuse? Opposite. I agree. What about that 3.7? Woohoo! Which trig function? Tan? Something you do in the summer? And what always goes next to the trig function, Luna, is the angle. Since I don't have it, I put a variable there. Equals opposite over adjacent. How do I find an angle? inverse or shift or second function, however your particular calculator works. This is my other beef, by the way, with that, is you have to type everything backwards. In other words, I like a calculator that lets me type square root of 9, not 9 square root, and especially for longer equations. But that will, I have had kids make it through Physics 12 with that just fine. And I have to put it in brackets. Do y'all get 73.6 degrees? I'll go 74 degrees. That's the 2 sig figs. So right angle trig is what we'll be doing about 90% of the time. However, when we get to the momentum unit, most of the collisions, if they're interesting at all, are not at right angle. We'll look at car crashes where they bounce off of each other, which is much more interesting. And using the sine law and the cosine law is the best way. You can avoid it. It is possible to do all of Physics 12 with nothing but right angles by breaking everything into components. Remember components? By breaking everything into components all the time. That's doable, but it's long. So, question C. I have here, solve for C, use the sine law. What if I hadn't said use the sine law? How would you know? Well, first of all, is it a triangle? Okay, check. Is there a right angle? So I can't use SOHCAHTOA. Then how do I know that I use the sine law? What I look for is a pair. And what I mean by a pair, Sam, is this. I look to see if an angle and the side across from it, if an angle and the side across from it, if an angle, ding, 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 and if anywhere I know an angle and the side across from it, if I know a pair, it's sine law. Otherwise, it's cosine law. Okay? So where it says, note, we use the sine law when we have, I'll just write down a pair. And what I mean by a pair is angle and side across from it, that's sine law. What is the sine law? Hey, I wonder if that's also on the reference section of my formula sheet on the page that has actually 2 pages on it with lots of small writing. I wonder. You didn't say sin, did you? Saying sin is a sin. It's called sine. Ryan, what is the sine law? Okay. Adjust it to this triangle. So it is going to be, I think, sine of big A over little a equals, what are we trying to find in this triangle? So sine of big C, we don't need the B part, right? Over little c. Mr. Dueck? Yes, Ryan? Call me silly, but is that 1 fraction equals 1 fraction again? Why, Ryan, yes it is. So I suppose somewhere along the way I could, as a shortcut, move stuff diagonally. Let's plug stuff in here. Big A is little a is 6.2. Big C is sine 72. Or I could have got the C by itself first and then plugged in numbers. I don't care which here. So if stuff moves diagonally to get the C by itself, I think, Emma, the C moves there, the sine 48 moves there, and the 6.2 moves to the top, I think. So I think I get this. C equals 6.2 sine 72 all over sine 48. And I get 7.93, 3 sig figs. Units, centimeters. Centimeters. By the way, Ty, you notice I have the habit, whenever I'm writing my final answer, you'll always hear me, after I write the answer, say units, because on a test, I'll take marks off if you don't put units on the final answer. Anywhere else I don't, but final answer, it's got to have units, right? Thumbs up so far, Logan? You gonna make it? You gonna make it? You sure? Because Michael's elbowing you. Continuing on. Oh, some of you need a few clubs of wisdom, believe me. D. Now, I said solve using the cosine law, but can you see how you can glance at this and figure it out? Sam, is there a right angle in this triangle? So, can't use SOHCAHTOA. Then you go zip, zip. You kind of move your eyes diagonally. Is there a pair anywhere? Do I know both of those? Sam, say no. Do I know both of those? Do I know both of those? Cosine law. If you want to be even more specific, you use the cosine law when you have two sides and the angle between them. When you have side, angle, side, or hey, when you got a little sass. Side, angle, side. Okay. I'm trying to come up with stuff to help you remember, okay? I mean... So. But really, even more when I don't have a pair. By the way, if you can't solve it with a cosine law and you don't have a pair, what that really means is you don't have enough information to solve that triangle. You need something else. So go back and check. You missed something in the question. What is the cosine law? You know, Sam, it would be convenient, perhaps, if... I wonder if that was on the small reference section of my formulas sheet. Is it there? Yeah, Ryan, you did such a good job of reading the last one. What's the cosine law? Stop, stop, stop. That looks very familiar. Okay, I always think the cosine law is Pythagoras for a triangle that's been squashed or stepped on, so it's no longer a right triangle, and you need a fudge factor. And what's the fudge factor? Minus. It's actually even more basic than that. However you put the cosine law together, like what if you don't have A's and B's and C's? What if it's X's and M's and J? You know what? First letter and last letter match, the other two letters go there. The other two sides, the other two variables go there. In other words, here and here are opposite from each other. Now, I'm going to cover the cosine law here. We're going to look at it a little bit this unit, but it won't be on this test. It's going to show up right around Christmas, a little before Christmas, if I play my cards right. So, in this case, what are we trying to find? Little c, so I'm going to go c squared equals, what's little a? Yeah. Squared plus 8.4 squared minus 2 times 6.2 times 8.4 cosine of big C, 65. If you have a good calculator, you can type all this in one fell swoop. You can go 6.2 squared plus 8.4 squared minus 2 times 6.2 times 8.4 cos 65. And this is also why I like a multi-line display. You can then read through it and double check to make sure it matches what you've written. Most common mistake with the cosine law is people tell me that the answer is 64.98. We haven't found C. What have we actually found? C squared. And this brings us to our familiar reference. How do I get rid of a squared? Don't forget to square root with the cosine law. Okay. Turn the page. Using the cosine law or the sine law to find an angle is a bit tricky. By the way, look at example E. Sine law or cosine law? And how do you know? Okay, sine law, because there's a pair. I'm not going to cover that right now. I'm going to see if you know how to do it. It's going to be part of your homework. Otherwise, I'll talk about it next class. And the real biggest pain, by the way, look at triangle F. Sine law or cosine law? How do you know? cosine, because there's no pair. Also, I see side angle side. See it on the left-hand side? G, cosine law, because there's no pair, finding an angle. That's the biggest pain. And I haven't covered that with you. I think you saw it last year, but I want to give you some time to work on the homework. And I normally don't like giving homework over the weekend. When do I see you guys next? But because today is Wednesday, I'll live with giving you a big assignment, and I'll say you can get it done Thursday, you can get it done Friday, and I know most of you have study blocks. So I try to avoid giving out homework on the weekend. With the strike this year, I'm not sure I'll be able to pull that off anyhow, but we'll see. So this is actually from the lesson. This is not part of your homework. Your homework is this thing that I called the basic math review assignment, and here it is.